And welcome everybody. Today our first lab is going to be all about flame tests, and flame tests take advantage of a property studied by Niels Bohr back in the early 1900s, in which he used experimental evidence to figure out where exactly the electrons are in the atom. Rutherford's model prior to that had no explanation about where the electrons are, but Bohr said, I can figure it out using some experimentation. And in this experimentation, he discovered that if you energize electrons the right way, it undergoes what's called absorption. And as you can see in the diagram that I'm drawing out now, absorption occurs when electrons absorb the right amount of energy and jump to a higher energy level. Then it has to go back to its starting point, and in doing so it undergoes what's called emission. And in the process of emission, that will give off light and heat, releasing energy to get back to its starting point. Now that's the phenomenon we do see. So whenever you see light, you see colors, you see both, you feel heat, warmth, whatever, that is from the emission process. He also found that this happens uniquely with different elements. So what we're going to do today is demonstrate this with several element metal solutions, and you're going to see this phenomenon in action and see what happens when you energize different metal solutions with a Bunsen burner, thus creating what are called the flame tests. So as you watch the video, follow along using the lab handout that your teacher has provided you. Okay, we will be using these substances called metal nitrates. Now, metal nitrates are solutions that are metal that have a nitrate ion attached to it. They have the generic formula MnO3, and the NO3 part is the nitrate. This is to make sure that everything stays dissolved in solution. Now, the first solution that you will see being used in this experiment is something called lithium nitrate. So lithium nitrate has the chemical formula LiNO3. Nitrate has a -1 charge. Lithium has a +1 charge. So the nitrate combines with the lithium, and you get something that dissolves. Now, the lithium part here is the important part. This is the part that you will see in action when we put the solution in the Bunsen burner. Now watch. The second solution that we're using is something called strontium nitrate. Now, strontium nitrate is also a metal nitrate. However, this one's a little bit different. The reason is because strontium has a +2 charge as opposed to a +1 charge. So we have two nitrates that go with it because strontium is an Sr +2. So that's why we are using this one. The third solution that we will be using is calcium nitrate. Now, as you noticed, as you watch it ignite, you'll see that it takes a little bit of time to get to the point where you can see a color. That's just unfortunately how the calcium nitrate behaves. I will also point out that calcium, also like strontium, has a Ca +2 charge for both calcium and for the strontium as well. Okay, the fourth solution that you're watching now is sodium nitrate. Sodium nitrate has the formula NaNO3. Now, this is a lot like lithium in that it has a +1 charge. And like lithium, it's in the first column of the periodic table. And you'll see that with the +1 charge, just like lithium, they have similar chemical properties, and that's more relevant in later units when we talk about chemical reactions. All right, next up we have barium nitrate. Barium nitrate is very similar to both strontium and calcium nitrate in that it has barium with a +2 charge. So again, barium has a +2 charge just like calcium and just like strontium. And if you look at the periodic table, you'll see that they are also in the same column, just like the lithium and the sodium were as well. The next solution is copper nitrate. So copper nitrate has a similar formula to barium nitrate. in that it has a metal with a +2 charge. Now, copper can form more than one charge. In this particular case, it's a +2. It is in the middle of the periodic table. If you're looking up the periodic table on your own, you'll see that it's in the middle. But just like barium, it also has a +2 charge. The last solution is potassium nitrate. Now, potassium nitrate has the formula KNO3, and you will see that just like the lithium and the sodium, there's only one nitrate paired with it, so that means K has a +1 charge. Now, if you look at the periodic table, you'll see potassium is in the same column as sodium and lithium. You'll also notice that it is sort of a violet color or a lavender color. Not everybody can see that. So we're going to repeat potassium nitrate because the lavender is not always easy to see. However, this time we're going to be doing the experiment with something called cobalt glass. Cobalt glass is a dark blue colored glass. You might see it in stained glass windows. And as you can see, when you add the glass in front of the lens, it changes the color of the potassium. Now that's important because potassium in a mixture is oftentimes hard to see. Cobalt glass will reveal that in a mixture, and it works only with the potassium ions. And that was flame test. I hope you enjoyed watching the experiment. I know it's a lot more fun to do in person, but unfortunately circumstances are what they are. Don't forget to answer all the questions that your teacher is asking you to fill out and finish, and make sure that you submit it through Schoology at the appropriate due date. Hopefully we'll be able to do more videos in the future related to some more exciting and interesting experiments and topics later on in the year. So have a great rest of the day and the rest of the week, and I'll see you again later.